DU 2022 Introductory MME question number 1 part A. Let fx equals to absolute value of 2x minus 6 graph fx. Okay. So basically you can see that 2x minus 6 is equal to 0 when x is equal to 3. Okay. So we can write fx equals to 2x minus 6 if x is greater than 3. Okay. We can write it as 0 if x equals to 3. And we can write it as 6 minus 2x if x is less than 3. So why this is happening? So if your fx is of this type, mod of x minus a, this is equal to x minus a if x is greater than a. This is equal to 0 if x equals to a. And this is equal to a minus x if x is less than a. So this is happening by this definition. Okay. So now we want to graph. So to draw the graph, let us observe something. So first of all, we know that at x equals to 3, this is 0. So you put certain values. So this is x, this is y. At x equals to 3, this is 0. So suppose I put x equals to 0. If x is equal to 0, so we are going to use this. So this is going to be 6. Okay. And now if x is equal to 1, this is going to be 4. Okay. And if x is equal to, for example, 4, so this is, or yeah. So if x is equal to 4, this is going to be 8 minus 6, which is 2. So at x equals to 1, it is 4. Then if I take x equals to 2, okay, this is going to be 2. So how do we make the graph? We make the graph like this. So 1, 2, 3, 4. So at 3, it is 0. So when x is equal to 0, the value of y is 6. So 1, 2, 3, 4, 5, 6. Suppose it is here. Okay. So when x is equal to 1, the value is 4. So 1, 2, 3, 4. Somewhere over here. When x is equal to 2, the value is 2. So somewhere over here. So we are having a graph like this. And then when x is equal to 4, it is again 2. Something like this. Yes. So the graph will be like this. Okay. So now this is the graph. So comment on the continuity and differentiability of the function. See, the function is a straight line before x equals to 3. The function is a straight line after x equals to 3. So the function is changing behavior at x equals to 3 only. Okay. So to check the continuity at x equals to 3, what we have to do? We have to look at the value of f3. f3 is 0. Okay. Then we have to look at the left hand limit at 3. So which is limit x tending to 3. Now what is the left behavior of the function? 6 minus 2x. So when we put x equal to 3, it will be 0. Let us look at the right hand limit at 3. So which is going to be limit x tending to 3. And what is the right behavior? So the right behavior is 2x minus 6, which is 0. And you can see from the graph, as x approaches 3 from the left, the function approaches value 0. As x approaches 3 from the right, the function approaches value 0. So therefore, the function is continuous. Function is continuous at x equals to 3 as left hand limit is equal to right hand limit is equal to the functional value at 3. Okay. Now what about the differentiability? Now for the function to be differentiable, the left hand, so for differentiability at 3, the left hand derivative should be equal to the right hand derivative. Now you note one thing, from the left hand side, this graph is a decreasing function. From the right hand side, this graph is an increasing function of 3. At other points, there is no need to worry because straight lines are continuous and differentiable. The only point where we have a problem is x equals to 3. And we have already seen that it is continuous at x equals to 3. So for differentiability, the slope of these two lines from both the ends must be same. Now, if you look at the slope of the line from the left of 3, so the left hand derivative is equal to the slope of the line, which is the first derivative, okay? So which is minus 2. And if you look at the right hand derivative, which is d by dx of 2x minus 6, which is plus 2. So as the left hand derivative is not equal to right hand derivative at x equals to 3, the function is not differentiable at x equals to 3. Okay, so we have completed part 2 also. Does the inverse of a function exist? Now you can note that this function is not a 1-1 function. Why? Because at 2 it is taking value 2, at 4 it is taking value 4. In fact, any value is attained by 2 points. For example, if we talk about this value, this will be attained at this point and this point. So this function is not a 1-1 function. For the inverse of the function fx to exist, the function must be a 1-1 function. So you will say no, the inverse of the function does not exist because fx is not 1-1. For example, f of 4 is 2, f of 2 is 2, but 4 is not equals to 2. Okay. 4 and 2 are two different points, but they are mapped to the same number 2. So this function is not 1-1. Okay. Also. Now, will fx have an inverse if x belongs to minus infinity comma 3? So again, let's make the graph. So the graph is something like this. Now they are saying that they are restricting the domain from minus infinity to 3. So from minus infinity till 3, so basically only this part of the function is concerned. That means my function fx will only be defined for x less than or equal to 3. So for x less than or equal to 3, this function was 6 minus 2x. Okay. And now this is a 1-1 function. It's a straight line and it's a strictly decreasing function. So yes, because the function becomes 1-1. Will fx have an inverse if we go from 5 to infinity? Same reason. If we go from, see, this is 5, for example, this is 5. So we are going from 5 to infinity. So we are going here on x-axis and this is my range. So again, this is a straight line. Okay. And this will have an inverse because it is a strictly increasing function. A strictly increasing function is 1-1. Yes. Same reason, because the function is 1.